Unit 6B, Software Security, Web Application Security, the particulars of keeping web applications secure, specifically web applications exposed to the outside internet, but this also applies to internal web applications. Software and security, how any website that does anything useful works. You can it's a combination of custom development, commercial site software, or open source and free site software. They may have different origins, they may have different kind of contractual relationships between you and our organization, but it's all part of the software environment you have when you develop and deploy a website. Now, websites are complex mixtures of components, which makes keeping them secure particularly challenging. They consist of web servers, typically IIS, Apache, there are other ones, Nginx, and so forth. There's server-side code, which is Java, PHP, .NET in general. You can also send code meant to be executed on a client side, which nowadays is typically JavaScript. In the past, Microsoft ActiveX has been part of that. And then you have the web browser itself. The browser itself has its own peculiar interactions and security flaws and so forth. So when you're building a website and you want to make it secure, you have to keep all these things in mind. Plus, you also have to keep in mind the underlying server operating system, the networking configuration, the client-side operating system, and so forth. Now, the book calls these threats, but actually, if you look, almost all of them are vulnerabilities. So I'm going to call them vulnerabilities, but for the sake of the book, they're threats. Information gathering, the exposure of information that's not intended for public use on your website, information about the site itself, how it's configured, what versions of software it uses, the sorts of things that an attacker can use to go after you. Open administrative interfaces. Websites have administrative interfaces, things like WordPress and so forth. Content management systems have administrator accounts with user IDs and passwords. If these aren't properly secured, that's an issue. Authentication and access control failure as pertaining to the end user. Can the end user access parts of the website they're not supposed to see? Can people get in without being properly authenticated? Can a malicious user steal a real user's authentication credentials? Input validation failures. Can a user, malicious or otherwise, send input into the web application that isn't properly validated and hence does something it's not supposed to? Parameter validation failures, similar to an input validation failures. And in session management failures. The web itself is based on HTTP, which is not a session-based protocol. It's basically, I ask for a website, you give me a website. I ask for the next website, you give it to me. There's no connection between the first and the second website in raw HTTP itself. So we have to use various tricks and techniques in order to maintain a session where you maintain a common identity, where you maintain a history of what a user's done before. For example, in a web shopping cart type site, you need to know what the user has selected in their shopping cart before they go to the particular link that allows them to pay for and have it delivered. Threats. Information gathering. Attackers will gather all available information about your website to find vulnerabilities, include comments left in the HTML itself. Programmers may say things like, this section here doesn't really work, or comment it out because it's used for test purposes. An attacker will find these extremely useful. Visible server-side code. Generally, code that runs in your web server should not be visible to the end user. However, misconfiguration can make it visible. Detail information about software versions. What version of WordPress is this site developed in? Well, an attacker who knows a precise version can look up specific vulnerabilities concerned with that version and then very quickly focus on exploiting those. And in verbose errors that give away internal server information. In my personal experience, Java is notorious for throwing all kinds of stack trace errors on perfectly innocent sorts of mistakes, things that will confuse a normal user and fascinate an attacker. So what you should do, limit information given out by your website to the minimum necessary. Don't give away verbose errors. Don't tell anyone what version of software you're using or even what it is. Make sure that the server-side code is not ever visible to an end user, and scrub those comments and other stuff left in the HTML. It might be useful to developers, but it's also just as useful to an attacker once it's in production. Open administrative interfaces. Content management systems like WordPress, like Drupal, like Joomla, and other administrative tools have an administrative interface. Default or poor passwords, software flaws, and other problems can allow attackers access to the website through the administrative interface. If an attacker can get into the administrative interface, they can reconfigure a website to their liking, and that's not good. Authentication and access control. Authentication in this case is the end user, not the administrators. We just dealt with the administrators. Some of the flaws include guessable passwords, allowing users to have passwords like 1, 2, 3, 4, 5, 6, 7, 8, or password 1 or something. Poor password management, allowing users for sensitive sites to keep the same password forever, or allowing passwords to not be strong. Providing clues as to valid ID password combinations. Something that attackers might do is go to a website, enter an invalid ID and password, and see what the error message is. If the error message says that user doesn't exist, then they know it's the user ID that's at fault. If it says password invalid, they know the user ID is valid and the password needs to be changed. This is valuable information to somebody trying to break into your website. And then unencrypted credentials, being able to sniff credentials, being able to grab credentials from an end user client as cookies and so forth, being able to fake that the website is running under unencrypted HTTP instead of fully encrypted HTTPS, and then being able to see the unencrypted credentials, all that sort of stuff. Access control also means only grant access that the authenticated user requires. If you have different types of users on a particular website, like for example the Canvas website for UCLA Extension has students and teachers. Students should not have access to areas that are particularly private to the teachers. That's a very rudimentary example. Another example is that one student should be able to see their grade, but shouldn't have access to the grades of the other students. That's another sort of access control issue. Sometimes websites are designed so with a little bit of trickery, some people can work around the access controls and see information they shouldn't be allowed to see. Input validation failures. This is caused by allowing illegitimate input into the web application and then sending it to all the back-end stuff. Bad input not sanitized or rejection can cause harm, can cause a lot of well-known web application errors. Path or directory traversal, being able to walk the directory scheme of the web server outside of the web application and into other areas with sensitive information. SQL injection, being able to send raw SQL commands to a back-end database and have it execute those commands, a very bad thing. And cross-site scripting, which I think is more usefully called JavaScript injection, where you can send a script to a different end user of the site that executes something on that end user's browser that the original site never intended. So you're inserting scripting code into something that goes to somebody else. This can be enabled by tricky Unicode, URL and HTML encoding, and in other ways to make bad input bypass filters. There are a lot of ways evil input can be obfuscated to look normal. The rule you should follow is only accept known good input, because anytime you try to block bad input, a sufficiently skilled attacker can get around that by just modifying it a bit and making it look okay. It's always better to whitelist than to blacklist. Example 1, path or directory traversal. How does the application deal with resources in use? It's possible in this particular application to insert a malicious string as a variable here. You see where it says file equal ... slash ... slash ... like right here. That's where an attacker inserts something instead of a file name that actually has a full path. If you don't filter this here, you can end up walking outside of the directory in which the web application is stored and into a directory out in the rest of the file system, And here's a good example. You can get the encrypted passwords, if this worked, out of the Etsy shadow file, or vice versa. You can also get the Etsy password file. Note that in a Windows system, an attacker can navigate only in a partition that locates the web root, whereas in Linux he can navigate the whole disk. This is a case where in Windows you can actually set it up to be a bit more secure than in Unix. This is an example from OWASP, the Open Web Application Security Project, dealing with a path traversal problem with web applications. Basically being able to modify a parameter interpreted as a file name such that you can go anywhere in the directory system. SQL injection. Suppose you want to find users in a user database. What does this SQL command do? Well, username equals 1 or 1 equals 1. This or 1 equals 1 here will always be true. So it's select from users where always true, and password equals password. So if you can craft a SQL command like this, send it to the backend database, it will send you every user. And here's an example of how it would work. You notice that there is the &20. That's because it stands for a blank space. You have to encode these because they can't be embedded in the URL as is. Don't worry about the MD5 function up above, and don't worry about the password equals foo down below, because for purposes of SQL injection, these aren't relevant. In fact, you can see that password equals foo has been commented out. The important point is, in this example, the attacker replaces a get string with encoded SQL that gets passed to the backend database. That should never happen. And you can go to OWASP to find more about this sort of thing. Cross-site scripting. Inserting a script into a legitimate website that is your script that gets executed in the user's browser and does whatever you want. Example 1, a cookie grabber. If the application doesn't validate the user input data, the attacker can easily steal a cookie from the user. All the attacker has to do is place the following code in any place where user input is allowed and where it's not sanitized to prevent this sort of script from showing up. If you can put this on a bulletin board, a discussion group, a comment or something, and you own the website evil.php, then you get their document cookies. Cross-site scripting is ubiquitous. It is very hard to protect against, and it can be very bad. It's located in the OWASP. Here we are. Yeah, OWASP.org. Again, they have a whole thing written up about this. Parameter validation errors. It's a type of input validation error. It includes things that aren't visible to the naive user, things like cookies, post request, and hidden field input. Generally, most user browsers, unless you've got a plugin on them, most user browsers as installed can't modify cookies or post requests or hidden field input. However, if you've got browser plugins of a certain sort in Mozilla, or you use web browser proxy software like, there's stuff like WebScarab and Burp Suite and things in Fiddler and stuff like that, most of which is available for free, that web browser proxy will intercept the request before it's sent to the browser and allow you to modify it. So the rule here is never trust what the client sends you. If you send somebody a field with a hidden field input, assume that it's been tampered with. Assume that a post request or cookies can be tampered with as well. Don't assume you're dealing with a normal browser that doesn't manipulate this stuff, because an attacker won't use a normal browser. Session management failures. The web, in particular HTTP, is intended to be stateless. Every communication is independent of what precedes and follows. There is no sense of a state depending on what happened previously. To make it stateful for things like e-commerce requires extra information, session IDs, defining the session and the user associated with it, and the state of the connection. An attacker that can guess a session ID can impersonate a user. A user that bypasses state can violate transaction rules. You can, for example, if you have a very badly designed web commerce site, somebody could potentially have a good shipped to them before they've paid for it. Or somebody could modify the price of a good before paying for it, and so forth. Basically, the threat here is I can impersonate your session identity if I'm an attacker impersonating a legitimate user, or I can do something that violates the expected transaction or workflow if I'm a malicious customer. Now, if you want more information about this stuff, OWASP, the Open Web Application Security Project, is the best place for it. Incredibly informative and useful. It's got how-to guides, software, free software for security testing, and sample guidelines and standards. The OWASP Top 10 is a definitive list of the 10 worst security issues they found, as of that date in the web overall. For 2013, you've got injection attacks, broken authentication and session management, cross-site scripting we've talked about. We haven't talked about insecure direct object references, but that path traversal kind of deals with them peripherally. Security misconfiguration, sensitive data exposure, no function level access control, never depend on the web site, the HTML itself to support access controls. You have to support them on the server-side code. Cross-site request forgery, where the end user's identity is stolen by a malicious character. Components with known vulnerabilities. Yes, make sure every version of every software you use has been patched in terms of the vulnerabilities. And unvalidated redirects and forward. You don't want your website sending a user unknown to you to a malicious website. And that's it.